Okay, we're back to the mock exam, number 82, calculator questions. So you were given this information and you were given that this was the velocity and you want to know what is the total distance from 0 to 2. So normally you would have to go back to the original function. However, we don't have an initial condition, and because it's a calculator problem, we can just use the calculator. So it's just going to be from 0 to 2, the absolute value of the function. You're going to put that into your calculator, and you get 2.2613, and that was choice D. Okay, here's 83. So you were given f prime, and you need to know when is there a max. So we find a max, or a min for that matter, by taking the derivative and setting it equal to 0. There's a 3. Okay, and we're going to cross multiply. And we're going to get that. Now, in order to solve this, you're going to go into your calculator and you're going to enter this into the y equals portion of the calculator, and then you're going to go into second calc, and you want to choose the option that says 0. And then you're going to be looking in this window from -1 to 9. So you want to set up your window to go just from -1 to 9, because those are the only solutions you care about. And from -1 to 9 there, it should hit the x-axis 3 times. So you're going to use second calc and then 0 to find those 3 solutions, and these are the 3 solutions. -0.59, 0.638, and 7.95. All of those are between -1 and 9. So next we're going to make a wiggle graph, and we're going to put those values on the wiggle graph. And we're going to be testing in f prime. Okay, so you're going to take values to the left and right of all of these intervals, and you're going to put it in your calculator. So the easiest way to do that is to put this function right here into your y equals, and then just go to table and pick numbers that fall to the left and to the right of these different 3 values. When you do that, you will get negative, positive, negative, positive. Okay, so this is decreasing, increasing, so there's a min. This one is increasing, decreasing, so there's a max. And this one is decreasing, increasing, so there's a min. And this question is asking for a max, and so there is a max at 0.638, and that is choice C. Okay, for number 84, you're told that R of T will tell you how much bacteria is in a container, and you know at T equals 0, so when time is 0, there is already 1,000 bacteria in there. Well, it's increasing no, there are 1,000 bacteria. Okay, and we need to find out how much bacteria is there at time T equals 3 hours. So that would mean all the bacteria that built up from 0 to 3. But you need to know how much you had when you started, so we're going to have to add the 1,000 to that, and that is choice D. And I just want to say it is not R of 3, okay, so it's not that, because that will just tell you how much bacteria is in there at exactly 3. But we want to know what happened after 3 hours, at T equals 3 hours, so the time goes from 0 to 3. Okay, number 85, so you were given this information, and if you want you could draw a picture. G of 1 is 5, so this is 1 and this is 5, and G of 4 is 8. Well, let me just increase this line. There we go, and that would be 8. And so this is saying that, and this is just the interval from 1 to 4. And how do we know that G prime of C, so there's got to be some value C here, between 1 and 4 it's saying. It says there is a number C in the open interval 1 through 4, where the derivative is going to equal 1. So hopefully this sounds like the mean value theorem to you. That's the one where you do f of b minus f of a over b minus a, and then you set that equal to the derivative. So you are guaranteed for that to happen when the function is differentiable. It must be differentiable, right? Because, I mean, we don't know what it looks like, but if there's a hole, then how could we guarantee that there would be a value c? And that's why it's answer B. So of all the answers, that's the only one that has to do with the mean value theorem, that it's got to be differential, it's got to be continuous and differentiable. So it's continuous from 1 to 4 with the hard brackets. I hope you remember this, in differentiable from 1 to 4 soft brackets. And this is how they will test you on the mean value theorem, which I did say when we did mean value theorem that it's really like that, and the intermediate value theorem are the only ones that they'll actually like really ask you about the theorem themselves. Okay, now we're 86. This one is a little bit time consuming. I'm going to go through it. You may choose on the real test to skip a question like this, but we're going to try it. Okay, so they gave you 3 different double derivatives. They gave you f double prime, they gave you g double prime, and they gave you h double prime. And they want to know which one of these will give you exactly 2 points of inflection. So how do we get a point of inflection? We take the second derivative, so I'm going to do f first, and we set it equal to 0. Okay, so we're going to do f first, that's f. Okay, so it's nice and factored for us. We get 3 solutions: x equals 0, x equals 1, x equals negative 2. Can we make a wiggle graph? This is supposed to be a negative 2. Okay, and now we have to test values into f double prime. And you may be thinking, oh my god, this is going to take forever. But it really is not going to be too bad. So I'm going to give you like an example. So if we want to try a number in here, so let's say negative 1. Well, remember, you're going to be putting that into this over here. So it doesn't matter what the value is, it just matters if it's positive or negative. So if you put a negative 1 into this x, you're going to get a negative sign. No matter what you put into this, you're going to get positive because it's squared. And if you put a negative 1 in here, negative 1 plus 2 is 1, and 1 to the third power is positive. So a negative times a positive is negative, and a negative times a positive is negative. So I know this is negative. And that's what you're going to do for each one. You don't figure out the exact value, just figure out the signs. And you should get these signs. Okay, so where is there a sign change? There's a sign change here at negative 2. There is a sign change here at 0, but there is no sign change at 1. So that means there are 2 points of inflection, and we're looking for exactly 2 points of inflection, which would make us think that this is the winner. But some of these choices involve more than just one, so we have to try them all. Okay, so f double prime definitely works. Okay, now let's try g double prime. And if you didn't quite get the hang of that, so then as we do more and more of these, you'll see it'll get a little bit better. So g double prime is this. Okay, so this one, so we're going to take that and we're going to set it equal to 0. Now, because it has a plus 1, we cannot find what the values are as easily as we did before. So you're going to have to put this thing into your y equals on your calculator, and then you're going to go into second calc and see where does it hit the x-axis. And it will hit the x-axis at x equals negative 1.53 and x equals negative 0.12. So we're going to make a wiggle graph. And remember, we're putting values in for the second derivative. Okay, so you should get these signs. Okay, so that means there's a point of inflection here because there was a sign change. There's a point of inflection here because there's a sign change, and that would, and we are looking for 2 points of inflection. So that would give us G double prime, sorry, it's not quite right, as well. Okay, and now we just have to do H double prime, so let's get rid of this. Okay, so H double prime is this. Okay, again, we're going to have to put this into our calculator because it has that annoying -1 there. So you're going to put it in. You're going to put this into your y equals. You're going to go into second calc and see where does it hit the x-axis, and you're going to get lots of values. You're going to get this, this, and this. And when you make your wiggle graph with all of these values, and you're going to substitute into the second derivative, and you will get these signs. Okay, so there's a sign change here, sign change here, sign change here, and sign change there. So there's 4 sign changes, which means 4 points of inflection. And we're looking for functions that will give us 2 points of inflection, so it cannot be H. So the answer that has F and G only is choice C. Okay, here's 87. So you were given this table about f of x. You could graph this, it makes you feel better. The only problem is that you don't know what's happening, like at 1.5 or 2.5, or anything like that. But just looking at the graph, if you look at the y values, you can see that from here to here it's decreasing, here to here it's decreasing, decreasing, decreasing. So f prime, so f is decreasing, we know that. So that means f prime will be negative. Okay, so we're going to look at our 4 choices. And A says f prime is negative, so we'll keep that. B says f prime is negative, we'll keep that. C says f prime is positive, can't be that. And D says f prime is positive, so it can't be that. So we're down to A and B. And so is it decreasing or is it increasing? So we can look at some slopes, and let me make some room here. Okay, so what if we look at the point 19 and we look at the point 24? If I use the slope formula, I'll get this. I'll get -5. Okay, now I'm going to look at 2 other points. Let's say 3, 0, 4, -3. I'll do the slope formula again. And I get -3. So what's happening as we're moving along this function? First my slope was -5, then my slope was -3. So what's happening to the slopes? Those slopes are increasing, right? Because -3 is bigger than -5. So our 2 choices were A and B, and the one that's increasing is B, and that was the answer. Okay, here's 88. We're towards the end now of these multiple choice questions, and they will get crazier and crazier. So basically, here's what you were given. You're given an f of x function, you're given a g of x function. And you're told that the line tangent to the graph at f, so the line tangent to this one at x = 2 is going to be parallel to the tangent line of g at x = a. So the thing that we should know is that slopes of parallel lines are the same. So why don't we just kind of start there? So let's find f prime. So the derivative of ln of something is 1 over that something times the derivative of the something. Multiply straight across, and we get that. But this is happening at x equals 2, so I'm going to put 2 in there for x, and I will get 4 on top and 5 on the bottom. So the slope is going to be 4 over 5. Okay, I'm going to erase. Now we know that the slope of the tangent line to G also must be 4 over 5 because slopes of parallel lines are the same. So let's find G prime. And we're going to set that equal to 4 over 5. Okay, so there's no way for us to solve this by hand, so we're going to set it equal to 0. So you can see this is a popular trend that you have to keep putting all these functions into your calculator under y equals, then go to second calc, and what is 0. And you will see that it hits the x-axis at 0.44. And that answer was C. So first of all, you could do a very quick check. Well, this is really A. It's not x, it's A. But it's x equals A. It says A is a positive constant, and this is a positive value. So at least thank God for that. But the answer is C. Okay, so here's 89, and you were given this, and because there's an x on top and it's an f of t, you should definitely be thinking second fundamental theorem of calculus, but it's really not because there's no d dx in front, okay? So, but don't worry, we're going to get there. So we're being asked about the average rate of change, so that, remember, that's this formula 1 over b minus a as it goes from a to b of f of x dx, and that's the general formula, and then we can plug in. So this is going from 2 to 5, we were told. So this is a and this is b. So we have 1 over 5 minus 2 as it goes from 2 to 5, but the function we are talking about is g. So g of x dx. And we are told that this average value is equal to 6. Okay, so I'm just going to make some room here. Kind of went backwards. Okay, so 5 minus 2 is 3, so we're going to just simplify this a little bit. And get that. Move it up. Okay, and so how would we go about solving this? Normally, you would take the antiderivative, and then you would have to put the upper limit 5 into it, and then you're going to put 2 in it. The thing is, what is the antiderivative of g of x? Okay, and this is where the second fundamental theorem of calculus is going to come into play. Okay, so we know that g of x equals this thing up here. Okay, what does g prime equal? So g prime equals the derivative of the right side. And now this is the second fundamental theorem of calculus. I'm running out of room here. So we know that g prime equals f of x. So since this over here, this is the average value of the rate of change. So it says if the average value of rate of change, so the average value of the derivative. So g of x is actually the derivative. So what is the antiderivative? It's f of x. So it's going to be f of 5 minus f of 2. This one's, a little difficult, and it all equals 6. And if you look at your choices, you are going to get choice A. I mean, did you have to do all of this work? Maybe not, but I feel like I don't know how you would know that. I'm not really sure how, maybe you would choose D, I don't know. But, I mean, A is the only one that makes sense. So, the thing is that they didn't give you that the average value is 6, they gave you the average rate of change. And you have to recognize that that would be the average value because it's this, and then the integral from 2 to 5. So the answer for that is A. That's a tricky one. Okay, now we're at number 90. It's an exciting moment. We're getting towards the end. So which statement must be true? Okay, so let's look at number 1. It's saying that it has to be defined. So let's look at a graph. It has to be defined at x equals a. So let's say this is a, and so if it's defined, there's got to be a point there, right? There's got to be some y value to go with that a. F of a, whatever that is. Then the limit as x approaches a will be f of a. Does that necessarily have to be true? No, because my limit could be up here with an open hole like that. Okay, and what would my limit be? It would be up here, it would not be down there. So it could be, but not necessarily, so 1 is false. Okay, let's try 2. So all you have to do is find one example of when it's not true, and then you label it as false. Okay, so for number 2, f is continuous at x equals a, so let's say that this is a, and here's our f of a. And it's continuous, okay, so we're not sure exactly how it goes, but something like that. Then the limit as x approaches a must be f of a. Okay, that's true, because if it's continuous from the left, it's going to bring you here. From the right, it's going to bring you here, so number 2 is true. Okay, and let's look at number 3. Okay, number 3 says it is differentiable at x equals a. So here's a again. Let's say this is f of a. Here's my point. Now, in order for it to be differentiable, it must be continuous. It cannot be, there can't be an open circle there. So, again, the limit as it is approaching a it's there. So it would have to be f of a, so number 3 is also true. So 2 and 3 are true, and that is choice C, and we're finally done with the multiple choice.